We need to expand fz equal to z minus 1 by z plus 1 in Taylor series about z equal to 0, and the same function in the Taylor series about z equal to 1. So first we are going to expand this fz about z equal to 0. So our function is fz equal to z minus 1 divided by z plus 1. Let me write this as z minus 1 and taking this denominator to the numerator, because I always need something like 1 plus z inverse or 1 minus z the power minus 1, so that we can use the expansions for this. So I am having here z plus 1, so let's expand this. We can write this as 1 plus z. So this is 1 minus z plus z square minus z cube up to so on infinity. The alternate signs for this expansion is for mod z strictly less than 1, right? This is the condition for the expansion. Let's multiply this z minus 1 inside this. What we get? It is z minus 1 minus z square minus z plus z cube minus z square, so on up to infinity. Let's separate this. Z minus z square, then plus z cube, then minus z the power 4 up to infinity, and adding this to, let's write minus 1, then minus, adjust with this minus inside the bracket, plus z. For this it is minus z square up to infinity. So z and z becomes 2z. We have also minus 1 here, and then minus z square, that is minus 2z square, right? So this is further equal to minus 1 plus 2z minus 2z square plus 2z cube up to so on for mod z less than 1, strictly less than 1, right? So here ends up the first part. Second part, about z equal to 1. Because we need to expand about z equal to 1, so we need the powers in z minus 1. So we need the powers in z minus 1 in the expansion, right? So we need z minus 1. So fz is this. We can write this as z minus 1 divided by, I need z minus 1. So let me write this in the bracket. Let me add and subtract minus 1. So this is z minus 1 and plus 1, then plus 1, that is 2. We need z minus 1, so I am taking 2 outside of this denominator. So this is 2 into z minus 1 divided by 2 plus 1. That is z minus 1 divided by 2 into, let's take this to be in the numerator. So I am writing this 1 plus z minus 1 divided by 2 inverse. So if I take this, the variable x, so what is the expansion for 1 plus x to the power minus 1? It is 1 minus x plus x square minus x cube up to infinity for mod x strictly less than 1. So let's use this expansion on this. For mod of z minus 1 by 2 strictly less than 1, the condition, right? So this is equal to, let's multiply this inside. This is z minus 1 by 2 minus z minus 1 whole square divided by 4 plus z minus 1 whole cube divided by 8, so on up to infinity for mod z minus 1 divided by 2 strictly less than 1, right? Or mod z minus 1 strictly less than 2. So hence is the required expansion. Alright, thank you.